So we're now going to move to 4.5. What we're doing, oops, I just realized I made a mistake here. This is all quadratic. Apologize for that. So this is all quadratic inequalities. Chapter 4 was pretty much all quadratic, and we'll be looking at quadratics here. Again, I want to remind you that you can still use everything we learned in 5.6 to solve all these inequalities. So set them equal to 0, test your intervals, and often running. However, what happens in 4.5 might be a little faster, because what we're going to take advantage of is the behavior of the graph. We know right away, just by looking at the lead coefficient, right, if our parabola is going to be opening up or if it's going to be opening down. Right here, the lead coefficient is positive. Here, the lead coefficient is negative. So we've got that. We also, if needed, there's a pretty easy way to find the vertex. All right, so that's h is negative b over 2a, and k is f evaluated at the h value. So if needed, we can always find the vertex easier. But the graph, right, basically tells us a lot of information as you're going to see. And then with that knowledge, if we find our x-intercepts, right, I think, right, so this basically takes us what we've been doing, right? We've always been asking ourselves, when are we equal? So, when does f of x equal to 0? So the idea then is, here's what's going to happen. If I can find where I'm crossing the x-axis, and if I know that my parabola is opening upwards, then the graph has to be doing something like this. Absolutely positively has to, because I'm crossing the x-axis at that point, and then I'm opening up. So something like this has to happen. If you wanted to, you can find the vertex even to verify where that bottoming out is, but that's not always necessary. This is just, if and only if you have to, if you're still struggling. But we can see that here we're positive, and down here we're negative. So I can start answering the question, right, when is f of x greater than 0, or when is f of x less than 0, by just taking advantage of my x-intercepts, where I'm crossing the x-axis, and knowing how my parabola is behaving. In this case, the lead coefficient is positive. If we had the other case, if I had an x-intercept and an x-intercept, and we knew that my parabola is opening downwards, again, that would be my lead coefficient is negative. Well, again, we have to cross the x-axis that location, and since my parabola is opening downwards, I have to be behaving this way. So here's where we're positive, and here's where we're negative. So again, by taking advantage of my x-intercepts and taking advantage of my behavior of the parabola opening up or down, I can pretty quickly, right, decide where am I positive, where am I negative, and I can real quickly satisfy or solve some inequalities very, very fast. So I'm basically taking full advantage of the fact of the behavior, the graphical behavior of this. It kind of reduces the amount of algebra that I have to do. The only algebra I need to do is finding the x-intercepts. Combine that with the behavior, and we get a really quick, rough estimate of what the sketch looks like. And then it's pretty obviously just being able to read whether we're up or we're down or we're positive or negative. All right, so let's see that in practice real quick, and we'll just do some more examples as we move forward. So for this guy, right, it all begins with the fact that I got to solve when am I equal to 0. Here we can utilize factoring. I think I factored it right. And so we're basically having zeros at x equals 4, negative 2. My lead coefficient is 1, so this is greater than 0. So without doing anything else, here's a really quick sketch of the situation. I'm crossing the x-axis at 4. I'm crossing the x-axis at negative 2, and my parabola is opening up. So my parabola has to be doing something of that nature. So I'm wanting to know, when are my f of x's greater than 0? So essentially, when are we positive? So it looks like on that interval, right, which is negative infinity up to negative 2, we don't include it. As a matter of fact, I probably should have used some open circles there because it's a strict inequality. And then it looks like this interval here, some from 4 to infinity. So I don't even need to go to my graphing calculator for this, because the graphing calculator is just basically going to show me that same picture. So I'll let you guys check it graphing calculator wise. I'm basically using my knowledge of what the graph's supposed to be in my x-intercepts, and then I get pretty much a, dare I say, an obvious answer. What I want to go, though, what I will say is, notice this is falling very much in line with what we learned in 5.6, right? We find where we're crossing the x-axis, right, and then we test our intervals. Here I'm not literally testing the intervals, though. I'm just using what I know behaviorally about the graph. It's opening up. This is what has to happen. Maybe it does this, right? Maybe it does it even more pronounced, but I don't care the shape, right? It's above and below the x-axis at those locations. So that's pretty much what has to happen. I think I'm off the table there, so oops, sorry. Hope you can see that answer. So the next one, again, it all begins by finding my x-intercept. So when does this graph equal 0? What I'm going to do first is multiply both sides by a -1. That makes this a little easier to factor. I think we get x minus 3 and x plus 2. So x equals 3 and x equals -2. All right? And so we're crossing the x-axis, right, at 3 and -2. Looking at the original function, my a is equal to -1, so my parabola is opening downwards. So putting this all together, right, it doesn't matter if it's flat or short or whatever, this graph has to be doing something of that nature. Has to. And so we can see, right, when is my f of x's, when are they greater than 0, when are they positive? Well, all right in that stretch of intervals right there. It's a strict inequality, so I should have some open circles there. So it looks like our answer is between -2 and 3. All right, and again, you can verify that with your graphing calculators. I already kind of have a really good sketch. Again, if you wanted to get a better sketch, you can actually find the vertex. But I just think with the combination of my x-intercepts and knowing whether I open up or down, I have a really quick sketch to basically analyze the inequality that I'm trying to do. So sometimes it's that fast. You'll see some others where maybe finding the vertex will kind of help us out here. Alrighty, so there's your introduction to 4.5. Again, we're focusing on solving quadratic inequalities. We're using the same idea. We got to set it equal, right? Find out what makes us equal, in this case x-intercepts, and then I'm taking full advantage of knowing what the lead coefficient is positive, negative, to show me the behavior of the graph. Those two things combined, 99.9% of the time, give us what we need to go, and it's probably much faster than doing 5.6. Alrighty, so obviously some more examples coming soon. I'll see you in those videos.